we're going to introduce you to summation notation. In summation notation, looks like this. You may have seen it before. It is a Greek symbol, and this symbol just means sum, means we're going to add things up. We're going to have at the bottom of the sum, we're going to have our starting point. So this is our initial value. And then this is our variable. Sometimes it's x, sometimes it's I, sometimes it's t. It just depends on the variable or the letter you choose to use. Up here you're going to have your stopping point. And then in front of the sigma, you're going to have your rule. So for example, maybe we have x plus 1. So this is going to be our rule, and this tells us what to do with each of the x's that we plug in. So what we're going to do is we're going to start at the initial value, which is 0, and we're going to plug it into x plus 1. Then we go up 1, so then we go to x equals 1, and we plug in 1 for x plus 1. Then we keep doing that until we get to the stopping point, which is 4. Then we take all of those values that we found when we plugged in and we add them up. So in this first example, it says we're going to express the description of a sum using summation notation, but I'm also going to actually show you how to add this up. So we want to start, this is our starting point, our initial value. We're going to start at x equals 1, and we're going to stop at x equals 4. And the rule that we're going to use is x squared plus 6x. This is the summation notation for the description given to us in this problem. But now what we're going to do, in addition to just writing the notation, I'm going to show you how you can actually find the value of this. So we're going to start with x equals 1. That's our starting point. And I'm going to plug in 1 for x. So I'm going to get 1 squared plus 6 times 1. And then I'm going to add that to the next expression that we get from 2. So I'm going to plug in 2 now. So this is when x is equal to 1. Now we're going to do it for x is equal to 2. So I'm plugging in 2 squared plus 6 times 2. Then I'm going to do the same thing for x equals 3. I'm going to do 3 squared plus 6 times 3. And then I'm going to do the same thing for x equals 4. I'm going to plug in 4. So I have 4 squared plus 6 times 4. Then I'm going to actually go ahead and find all of those values and add them up. When I do that, I'm going to get 90. So I would take 1 squared, which is 1, plus 6. So this is 7. So in the first parentheses, I get 7. Then in the second parentheses, I get 2 squared, which is 4. And 6 times 2 is 12. And I take 4 and 12, and that gives me 16. Then I take 3 squared plus 6 times 3. That's 9 plus 18 is 27. And then I get 4 squared, which is 16, plus 6 times 4, which is 24, which is 40. Then when I add all those values up, so I take 7 plus 16 plus 27 plus 40, and you're going to get 90. So it can be a little bit tedious and lengthy, but it is not difficult. So literally all you do is you plug in all the values from your initial point to your ending point, and you add all those values up. Now I'm going to show you how you can calculate this on your calculator. Now some of you might not have this option, but most of you probably will. If you don't have this option, then you'll just have to do it by hand. However, if you do have the option to use summation notation on your calculator, it's always nice to be able to check it. So to do the previous problem or the previous example on your calculator, you are going to first hit the math key over here on the left. Then you are going to scroll down and you're going to look for summation notation. On my calculator, it's option 0. And I'm going to hit enter. And then it's going to come up when you can put in all those values. So I'm going to put in x equals 1. That was our example where we had a starting point at 1. So I'm going to use the variable button on my calculator, which is right here in the center next to my alpha button. And then I'm going to put in 1 because that's my starting point. And then I'm going to put in 4 as my ending point. And then in parentheses, I'm going to put x squared. Whoops. I'm going to put in x squared plus 6x. And then I'm going to arrow out of the parentheses and I'm going to hit enter. And it's going to tell me that the answer is 90. In example 2, it says express the description of the sum using the summation notation. So it says we want to write the sum that results from adding the number 2 4 times. Well, in this case, we don't want to change the value that we're adding. We just want to add 2 4 times. So I'm just going to use the constant function that has no x in it. And I'm just going to do it 4 times. So this would be my notation. And then if I want to actually find the value for the first 2, then I would add the second 2, then the third 2, and then the fourth 2. And that would give me 8. Now, because there is no x to plug in here, I just use the constant function 2. For example 3, it says find the indicated sum. So I'm going to start at 1. I'm going to plug in 1, and when I plug in 1 to x, I just get 1. Then I'm going to go to 2. I'm going to plug in 2, and when I plug 2 into x, I just get 2. And I do that all the way up to 19. When I add all that up, we get 190. And you can check that on your calculator if you'd like. Example 4 says find the indicated sum. So we're going to do this from 1 to 5. So I'm going to plug in 1. This time we're using a's instead. It's just a variable change. So for the initial value, when I plug in the first value, I get 1 times 1 plus 2. That's for a is equal to 1. Plus, now I'm going to do it for a is equal to 2. I'm going to plug in 2 times 2 plus 2. Then I'm going to do it for a is equal to 3. I have 3 times 3 plus 2. Then for 4, and then for 5. Now I have to actually add all this up. So here I have, in the first parentheses, I have 1 times 3, which is 3. In the second parentheses, I have 2 times 4, which is 8. In the third parentheses, I have 3 times 5, which is 15. In the fourth parentheses, I have 4 times 6, which is 24. And in the last set of parentheses, I have 5 times 7, which is 35. And now I have to add up all of those values. So I take 3 plus 8 plus 15 plus 24 plus 35. When I add those all up, my final answer is 85. Now we're going to talk about partial sums of a sequence. If I list out all the terms of a sequence, I would have the first term, then I would have the second term, the third term, the fourth term, and it goes on. If I wanted to add up the first n number of terms, that is called a partial sum. Now there's financial and scientific applications to this that we're going to get into later in the course, but for right now I just want you to understand what the partial sum means. And so what this means, if I wanted to add, so this would be an example, if I wanted to add the first 3 terms, the notation would be S3, S for sum, and 3 means you want to find the sum of the first 3 terms, and you would just take the first term plus the second term plus the third term and add them up, and that's what S3 would be equal to if we were talking about finding the first 3 terms. Now, something people get confused with is the difference between AN and SN. AN is the actual term in the sequence, where SN is the sum of the first n terms. So if I ask you to find AN, that means you're looking for a particular term in the sequence. And if I ask you to find SN, that means you're looking for the sum of the first n terms. So to make sure you understand the difference between the two, we're going to go ahead and do this example. We're going to find S3 and S5, given that AN, the sequence, is n squared. So AN is n squared. So if I wanted to find A3, that means that n is equal to 3, and I would plug in 3 into my sequence to find the third term. So if I plug in 3, that's going to give me 9. So this is the third term. That's A3. If I wanted to find S3, that is the sum of the first 3 terms. So I would have to find A1, which means I plug in n is 1, and I would get 1. I would find 2. To find A2, I plug in 2 for n, that gives me 4. And then to find A3, that's 9, because I plug in 3 for n. So S3 is when I add all those values up, which would be 14. So there's a difference between S3, which is the sum of the first 3 terms, and A3, which is actually the third term. So now let's find A5 versus S5. A5 is 25. That's the 5th term. So I would plug in 5, and 5 squared is 25. So this is the 5th term. But now to find S5, I need to find A1 plus A2 plus A3 plus A4 plus A5 and add them all up. We've already got A1, A2, and A3, so that's going to be equal to 14. But now we still got to find A4 and A5. A4 would be 16, and A5 is 25. So I would have to add all those up and get 55. So S5 is 55, and A5 is 25. So hopefully showing you side by side A3 versus S3, you can see the difference between the two. And when we get later on into the course, we'll go through the applications on how we can use the partial sums.